Hey everybody, it's time to have some fun with robots. Who's up for that? I always love the silent mic. It's like, yeah, that's awesome. What we're going to try to do today is, just because I love demos so much, we're going to build a session here full of demos. Right, so fingers crossed that everything will be working. What we're trying to do is think a little bit about, could we bridge virtual worlds with real worlds and do that with the help of IoT? And can we do that with the help of robots? Now, I didn't have the chance to really bring a massive robot with me, so I brought a few smaller devices with me, which I'm going to introduce in a little bit. So what you can expect from this session is a few things. First and foremost, have a look at a little bit, dive deep into AWS IoT, how we can use that, with things like a Raspberry Pi to potentially control animate objects via Bluetooth, channel that back with AWS Lambda to the AWS Cloud, use Amazon Alexa voice services to use my voice to control some of these objects with the help of an Alexa skill. And then lastly, we want to bridge that then together with the virtual world. And here we're going to use Amazon Lumberyard, which is the game engine of Amazon. And we're going to do that together with Cloud Canvas, bridge it all together so that we can control a virtual robot and control a live robot on stage and synchronize them together. All right, so let's start with the physical world. And the first thing that we need here is a few components. Well, what I decided to use here today is actually a little Sphero robot that I have here with me. You might have heard of a similar product that Sphero is building, which is called the BB-8. That was one of the very popular products, I should say. This is the Sparker, so this allows me to program this little robot itself, and you have a nice little transparent view of it. The next thing that I'm going to use today is a Raspberry Pi. Raspberry Pi is awesome kind of tools. We see one here connected. Small little computer, can program it with anything. Now the new version 3 comes with Bluetooth, so that's awesome. So I can connect that to my Sphero. And this Raspberry Pi obviously allows me to connect to the internet, allows me to connect to the AWS cloud. So what we're going to try to do is we're going to take that Sphero robot that we want to control. How do we do that? We're going to do that via Bluetooth using the Raspberry Pi. That's my local kind of point to control things. But now I want to control this from a cloud environment. So what I'm going to do is I'm going to use the Raspberry Pi to talk to AWS IoT. So it's going to use the MQTT protocol to actually talk back and forth between AWS IoT to give it commands, roll around to this, etc. And the robot will also send things back, like, for example, I detected a collision, etc. And to make that happen, we're going to use the AWS IoT device SDK that we're going to have on the Raspberry Pi. And I'm going to make use of a very useful open source project. If you haven't heard about it, it's called Cylon.js. And it's a really great library if you work with robots or kind of robotics tools or things like Spheres. It comes with libraries in Node that makes it really simple for you to control a lot of these objects with a few lines of code. And I'm going to show you this in just a bit. Now, the other thing that I wanted to do is, if we have a Sphero like this that rolls around, that's kind of fun, but it's a visual thing. So how about we give an audible thing to it too? So one other thing that we can do is, since we now have the ability to send messages back and forth between AWS IoT to other devices, what I can also do is I can send these messages back to another Raspberry Pi that is potentially connected to an audio system. And what I want to do now is to have the ability of having that Sphero roll around and have messages being sent back and forth, so that when the robot goes off, it should say, "Hey, go, go, go! I'm rolling," or "Wee, I'm going a little bit faster." So what we're going to do here is we're going to send the action roll, for example, to the AWS IoT platform. Any audible subscriber that is subscribed to the AWS IoT topic will listen to that action where it rolls, and will then decide, okay, when it's a roll, I should play a certain audio file, which you should be able to hear in your headset in just a bit, and that's the reason I have this one right here. So enough talk. How about we bring this into a live demo? So the first thing that I'm going to do is, you should now, and obviously it's always the same thing. I forgot to mirror my screen, so bear with me for just 1 second. I should have tried this out just before. And now you do see my screen. There we go. And the first thing that I want to do is connect to my Raspberry Pi. I'm already connected here. Let's just make sure I'm still connected. I am. So the first thing that I got to do is I'm going to calibrate this robot. And the way I got to do this, I'm going to use the Cylon.js framework. I'm going to connect to my Sphero robot via Bluetooth. Here it comes on up, and I think we can now get the camera on screen. That little red dot, blue dot here behind will indicate its position on how I'm going to calibrate it first. All right, the robot is now calibrated. I'm ready to roll this robot now, but at the same time, I want to actually connect it also to the AWS IoT platform. So this little drive.js JavaScript file that I just loaded will do a variety of things. It will first and foremost, again, connect locally to this robot using Bluetooth, and it will at the same time connect to the AWS IoT platform. Now to test it, I put a few keyboard shortcuts in that allow me to just roll the robot a little bit around. Let's try that first.
Go, go, go! Whee!
There we go, and we're rolling the robot around. Now the good thing is, I actually publish certain language messages through the AWS IoT platform. So what I could do is I could say, how about we change this to Japanese? All right, awesome. Or a bit of Chinese. There we go. Awesome. Let's go back here. A little bit in front. Bit to the back. So we kind of got the right positions here. Also Korean, always very important. There we go. And switch it back to English. All right. So this is all working. Cool. We control the robot from a Raspberry Pi. We send messages back to the AWS IoT platform, which allows me to play the audio files that you are hearing. Now, I hate smokes and mirrors in the demo, so how about we have a look on how that really looks like. So what I'm going to do is, I'm going to go into the console here, and I'm going to click on AWS IoT. And here we see we now have successful connections that are coming in. I basically registered the thing here. I called it the robot controller of the type Raspberry Pi. Now, if I want to see what's going on, what I could do is I could listen. I'll make this a little bit bigger so you see it well. I could listen to the topic on which the Sphero sends its messages back and forth. And if I do the same movements again, let's see what's happening on the IoT platform.
Go, go, go!
And we see now that messages are coming through. So we get the roll messages that are coming through to the AWS IoT platform. If I change the language will be changed, and that's also how you get those audio into your headset. So these roll messages that come through are actually sent to another device that then plays that audio file. All right, so cool. We now had a physical world that we connected to our cloud environment with the Raspberry Pi as an interface. Now that allows me to do a few cool things, such as, for example, change the color of that Sphero. Because what we have is, in this thing, we have the ability in AWS IoT to set a shadow state. A shadow state is a virtual state representation of some property of your physical device in a cloud environment, which allows any application to change that value in a cloud environment and then synchronize that with the device. So one of the shadows that I put in here is, for example, the color. So if I change this here, edit this thing, and I change this to red, and I save this, we see that it immediately synchronized that color back. So we now have the ability to go from our AWS IoT console straight onto the Sphero. Cool. All right, so the first steps are kind of there. Let me switch back to my screen here. So let's analyze a little bit what we did here and how we enabled this. First and foremost, we made use of a few components. So we made use of the Cylon JavaScript framework, which allows me to very easily, with a few lines of code, you see there it says Cylon robot, which allows me to connect to a Sphero. I actually use the BB8 driver because it's the same Bluetooth Low Energy protocol as the Sphero Spark. But most importantly, I also use the AWS IoT Device SDK for Node, which allows me, with a few lines of code, to connect to the AWS IoT platform. How would I do that? Well, it looks like this. After allocating a thing in AWS IoT and registering it with a security certificate, I can download that security certificate on my hardware device, which would be this Raspberry Pi here. With the private key that authenticates this device with the AWS IoT platform, and the AWS IoT platform is authenticated to the Raspberry Pi using mutual TLS authentication. Now, a few lines of code like this allows me to first and foremost create the device, which allows me to publish messages and receive messages through, but it also allows me to set a thing shadow and say that's an object on which I can read and write, and I can get informed if there's an update that has been synchronized on my device. How do we send messages back and forth? Well, basically we have the ability to subscribe using the AWS IoT device SDK to a certain topic. Here I set anything that is sent to Sphero/topic, so anything behind, that's what the plus stands for, that's the wildcard. I want to subscribe to that, I want to listen to that. Right, and then a little bit further down the code, you see device on message, I execute something. So if I receive a message, then I execute something. So for example, if I receive an action, I process that action. Roll the robot around, play an audio file, etc. Or I can also send a command back if I say, if an action, sorry, command to the Sphero, if I send the command roll, then the robot will roll around. At the same time, I can publish messages back from my device, and that's what you see in the upper quadrant, where we basically publish the initial language that we set from the device, which in this scenario, I actually set to English. Now, the last thing that I did is I updated the color from my AWS IoT console, and the Sphero kind of immediately reflected that update. How do we do that? Well, with a few lines of code, the IoT device SDK allows me to listen to a delta value of the thing shadow. What's the meaning of a delta value? Well, it basically only sends back the changes that I've made that are relevant for the device to change. In this scenario, it was the color. Well, if the color is being sent back, I just say react on that delta, Sphero, use Bluetooth to just change that on the robot itself. So we now have the capability to roll the robot around, have it connected to our cloud environment. We gave our robot a voice. What we haven't done quite yet is to actually talk to the robot. So the next logical thing is, well, since it's connected to AWS IoT, I can actually now change thing shadows. How about I would use my voice to do so? So for those of you who might not be familiar with that device that is shown up here, it's an Amazon Echo device, and it's a device that allows you to talk to the Alexa voice services. The Alexa voice services gives you the ability to use voice as commands to call certain skills that you code yourself. It comes with a full ecosystem, but you can write your own skill using the Alexa Skills Kit, or in short, ASK. And those skills can either be running on your own server, on your own endpoint, etc., or in an AWS Lambda function. And that's what we're actually going to use here. So what I want to create now is the ability to say, could I use Amazon's Alexa's voice services to say, hey, Alexa, ask Sphero to change color to orange, for example, and then Alexa voice services should call an AWS Lambda skill that publishes this information on an IoT topic, says color should change to orange. My Raspberry Pi will receive that update, and at very moment will send this information via Bluetooth to my Sphero robot right here. If that was successful, then the Alexa voice services will get the text back for my Lambda function that says, I changed the color for you, awesome, and I see as a user that has worked. So let's try this out. So what you see up here, and if we could just get the camera on this is an Echo Dot device, so it's the smaller brother of the actual larger Echo. It comes with a smaller speaker, but it allows me to actually plug it into an audio system, which you should have on your headset. So let's just see if the connection is working. Alexa, say hello.
Hello.
There we go. All right. Alexa, how are you today?
I'm good. I hope you're doing well too.
I'm doing well because the demo is working so far. Yeah, awesome. All right. So let's try this out. I created a little skill. I called it the Sphero skill. Okay. Alexa, ask Sphero to change color to orange.
I changed Sphero's color to orange.
And now one little thing that I forgot to say is the Sphero has an automatic timeout of 5 minutes. So let me just reconnect, wake him up. There we go.
Hello.
Now he's waking up. Switch back to where we were here. All right. Alexa, ask Sphero to change color to red.
I changed
Here we go.
Sphero's color to red.
Awesome. Let's give this another try. Alexa, ask Sphero to change color to white. Alexa, ask Sphero to change color to white.
I
There we
changed
go.
Sphero's color to white.
Awesome. So now we have the capability to actually use our voice to interact with physical devices here. Now there's some really cool things that you can do. I, for example, used this Raspberry Pi at home, installed it against my light system, created a skill that I call, give me some harmony, and off go the nice little red lights when I come home. So there are cool things that you can build yourself now here. Now, in terms of the robot, how did we do that? Well, we created an AWS Lambda function, which is the Alexa skill that we created. And in that Alexa skill, I did a few things. I created an intent handler that allows me to change that color. Intent is basically what Alexa knows. Alexa has an intent that I gave her with the utterances of change the color to maps to the change color intent. Great. And it will basically push in any word that I say. That word I will then use to update my IoT shadow state. And that's what you see there. I create a little JSON where I say the state that I want, the desired state, is the color that I just set. And then the only thing that we need to do is tell AWS IoT to update that thing shadow. We will update that shadow. If that was successful, we send back a response that says, I changed Sphero's color to whatever color I set, and the Echo device will render that back. The Raspberry Pi on the other side will receive this update as a delta change. Notice, okay, that's not the color I should have. Sends a Bluetooth information back to the Sphero and says, please change that color into the color that was just set. All right, so far we achieved a bunch of things into our physical world. We have now the abilities to connect devices into the AWS IoT Cloud, have the ability to give it a voice, have the ability to use our voice also to kind of talk back to this robot and make it do little things. How about the virtual world? This session was about how can we bridge things together. We now have the right components in place. We have our device, or devices, if you want to make this plural, because that would be absolutely feasible, that are now connected to our AWS cloud environment. So the next thing that I could think of is, could I create a virtual world where I navigate a robot? If that robot navigates, then my physical robot should follow suit. To do this, we're going to use Amazon Lumberyard. Now, Amazon Lumberyard is a free AAA grade game engine that is deeply integrated with both AWS and also Twitch. And the best thing is, we give you the full source. You can use it in any way you want. How does it look like? It's an engine that allows you to basically render virtual worlds, also VR worlds. It's well suited for VR headsets too. And it comes with an IDE, an integrated development environment, to actually also navigate in that world, create your levels. And I gave you a sample here of a very simple level with low rendering on how we could play around with this. And I'm going to switch to this in a live demo in just a bit. Now, there's one challenge. And that is a challenge that we often find when we want to synchronize virtual worlds with physical worlds. This guy here works with impulses. Right, so this Sphero robot, I cannot give it an update of 30 different updates per second. But if we have a virtual world, we expect a frame rate of at least 30 frames per second. So what I can't do is, I can't just go ahead and say, take the XYZ coordinates that I have in my virtual world, and every time they change, send that information back to AWS IoT and send that information back to my Sphero controller. You could try it, but it wouldn't scale very well because you have just such a chatty protocol suddenly where you just keep sending messages at an extremely high frequency. So what we're rather going to do is, we're going to use the cloud canvas of Amazon Lumberyard. Cloud Canvas allows you to actually use different AWS services straight out of the Amazon Lumberyard engine. And in the IDE, the way you do it is you just draw nodes in and you connect them together and say, this is what I'm going to call, and this is the actions of how I define my logic within my game. So how do we map that then back? Well, if we call an AWS Lambda function, we want to send those impulses back to the Sphero but not with that high frequency around how quickly we change into that virtual world. Because what we have in the virtual worlds is a camera or a player position that generally drags behind that robot, and that player position will generally expose X, Y, Z coordinates. So what we're rather going to do is we're going to work with delta changes. And no matter what robot you control in the virtual world, and the physical world, you generally want to operate with delta changes to give impulses according to how quickly you want that robot to react. I wanted to show you something that is relatively close to real time, so I decided, let me calculate these coordinates every second, and then just send that delta that we have between every update to the AWS IoT platform. This republishes it via MQTT to my Raspberry Pi. The Raspberry Pi now gets that impulse sent to the Sphero, and the Sphero can roll. How would we do that then at that very moment? Well, in that AWS Lambda function, again, all that we need to do is load up, this time not the device SDK, but the normal AWS SDK for Node.js, and we can then create an AWS IoT data endpoint. That endpoint that you see right there is actually the endpoint for my Raspberry Pi that controls the Sphero robot. And if I connect to that, I can publish messages. So what I can do is I can calculate the delta, and then I publish that delta to Sphero/commands, which would then be the event is roll with that certain impulse delta that I just calculated. So let's try to put this in a demo. So we're going to try to connect to Amazon Lambda. I'm going to show you the IDE. I'm going to show you the Lambda function that allows me to calculate those deltas, send that back to AWS IoT, to the Raspberry Pi, and make our robot roll. And before I do that, I'm not going to do the same mistake. I'm going to wake up my Sphero first, because it goes into power save mode relatively quickly.
Hello.
There we go. And now the next thing that I'm going to do is Amazon Lambda is currently available for Windows operating system. I do have an issue. I have a MacBook here. So I figured, how about we just use some workspaces in the AWS cloud to do this? So what you see here now is using the AWS workspaces. I'm going to go into full screen so you see that properly. There we go. You now see the IDE of Lambda, and whatever you see here is completely rendered in the cloud, then sent using the PCOIP protocol of workspaces to my laptop. And you can see it renders really well, even though I'm on a choppy Wi-Fi connectivity here. Now I have a mouse here that allows me to actually navigate around in that level, and I can navigate around, operate with the different objects, etc. here. One other thing that I can do now is I could start playing this game, for example. So I can use my keyboard to now navigate this robot. Now I haven't connected it to AWS IoT. That's why this guy is moving not yet. Just want to show you a little bit on how Lambda would look like. So what we use here is some of the particles to create that snow. Particles also used from the engine to render a nice little fireplace like this here. And if I go under the trees, you will see that get the nice little rays that get rendered from the engine. Very simple for me to do that by dragging and dropping objects right into this world and navigating around. Let me cancel this here. For example, if I have this rock here, click on it, I can say that doesn't quite look right for me. How about we make that a whole lot bigger? There you go. So visual editing of my virtual world. How do I give that virtual world now the logic that I require? Well, to do that, we're going to use the flow graph up here. If I click on this, you'll see that I can give this certain actions, such as, for example, I got to use my scrolling correctly here. I would say if I push a certain button on my keyboard, then I connect my Lambda to AWS IoT, and every second we will take the position of this object and use Cloud Canvas to send this to the robot's position Lambda function. And there you go. Got to get the screen properly done here. Now the other interesting thing is that I can do this bidirectionally. So I can even use my voice to potentially talk to this virtual world. Let's try that out. Whoops, my apologies. I'll be quick on the mouse here. Alexa, ask Hipster to salute.
Hipster says hello.
And there we go. So we used an Alexa skill that called a Lambda function. That Lambda function basically interacted with our Lumberyard engine. We now connected again a part of the physical world, which would be my voice controlled system here in this scenario, the Echo Dot, and actually trigger a certain flow into my virtual world right here. How did we do that? Well, it's very simple. Again, there's a flow graph, and we have this little entity of the Hipster here. And if you look here, I actually pull a queue, an SQS, the simple queuing service of AWS. If I get a queue, I play a certain animation on my player where he basically salutes, and after he's done, he goes back into its relaxed position. So the flow graph allows me to do kind of visual scripting of my level and create a certain logic around it. And similarly, we created that logic to now have my robot interact with it. So my sphere is still alive. Let's have a quick look here.
こんにちは。にーはお。
I want to do this in
안녕하세요.
Korean. There you go. If I go to my game now here, what I can say is I can hit a certain button and say,
멤버얏
I connected to
연결되었습니다.
Lumberyard. And I think you should have heard that.
멤버얏 연결 해제되었습니다.
Maybe I should change that back to English after all. Otherwise, we don't know what we're doing here.
Hello.
There we go. All right. Back to my virtual world.
멤버얏 connected.
All right, now we're ready to roll, which means now if I interact with that virtual world, and if you get the camera, I'm not sure if it's up, onto the Sphero robot right here, if I start navigating my robot here, you'll see that the real world will now interact based on the movements that we're doing here. I'm going a little bit of back and forth. And we sent these updates using a Lambda function. So if you look very closely down at the bottom, you can see that there's a certain flow log that is coming back, which is basically AWS IoT responding with the messages that we sent back onto the AWS IoT platform. The Raspberry Pi picks it up that very moment and sends this information back to my robot. And if I go to my terminal of the Raspberry Pi, you see now that there are updates coming through of those Delta updates of what this robot should be doing. And at this very moment, we have joined those two worlds together. Similarly, if I go back to my AWS IoT console and I have a look at my Sphero topic, you would see that there are now those messages coming through. So if I take my virtual world here, put this not in full screen, but I put this in a screen that allows you to see both scenarios. You can see the live updates basically coming through, having that virtual world connected using a Lambda function that continuously calculates the deltas in between. Now the toughest part now here is to get this right. Shoop. There you go. And as I start rolling that robot here, you'll see that
멤버얏 connected.
There you go, the connect message came through, and now we can start calculating the different deltas, rolling the Sphero robot around that very moment. Going a little bit back, and the messages are coming through. Let's go all the way back into the other room. Well, there's a car in my way. There you go. There you go. Awesome. Alrighty. Thank you. Thank you. Really appreciate it. So just a little recap of what we try to achieve. Obviously, we're not going to go out and say, "Oh, let's all build this as a product out." But there's some really interesting lessons that we can learn out of that little pet project that I had here, which was to try to take a virtual world connected to real world and think about the different components that we have in between to put the glue in. And that's obviously AWS IoT when it comes to physical devices, how we effectively can change shadow states around and not really worry about how that works under the underlying hood. We use the device SDK to do those synchronizations. Think about how we can build some cool Alexa skills, right? What we can do with that, right? If we can connect it to a Raspberry Pi, there's a lot more that you can do than just control the robot. And then obviously, lastly, if you want to build virtual worlds, use any game engine. Amazon Lumberyard is one of them, and it nicely integrates with AWS Lambda and AWS IoT. I want to thank you very much for your attention. Thank you.